So
a couple announcements as your Labor Day gift. I'm working so hard in this class.
It's going to be a short time,
I
right?
bumped your test due date to Monday night instead of Sunday night.
Okay, thank you.
Your homework date is the day before, that's still Sunday, so you guys can work on that whenever. And I noticed quite a few of you are working on that stuff ahead of time, which is great. So any questions there? Another comment on these chapters in general. If you guys are going to spend any additional time really focusing in on some material, this is the material to hang your hat on. Especially the supply and demand chapter. If you really know that inside and out, this whole course, we're going to come back to supply and demand the whole semester, I promise you. So treat this material like an investment, like you're investing in yourself to make your life a heck of a lot easier later down the road in the weeks, so that you're not struggling with some of the supply and demand stuff, because we're just going to keep piling additional material on there. And if you don't have that proper foundation, a good foundation, it just makes that stuff so much more difficult. Okay? All right. Any questions? All right. So we left out last time defining consumer and producer surplus. And I want to take a little bit different approach to that this time, just to kind of show you a little bit more on justification for it. So I want to look at individual versus market demand. The two are intimately tied together. So I want to draw 4 graphs side by side. 1, 2, 3, 4. And here we've got individual Tom, Dick, and Harry. And the last graph is the one that we spend the most time on. That's the market. So we're going to look at the market demand. So give me a good, any good, any good, any good?
Fries.
Fries. Okay, we haven't heard fries yet. So let's go with the market for French fries. All right, so we're going to put a little Q here for Tom's quantity of fries. And then we're looking at Tom's demand for French fries. And so maybe Tom's demand curve for French fries looks like this. And then Dick's demand for French fries. His looks like this. And then Harry's demand for French fries looks like this. It doesn't really matter where you guys exactly place it, but this is helping us think about, well, everybody's different, number one. So everybody has different demands. You might be a fry lover or a fry hater. And so the market is the summing up of the individuals. And so I kind of drew Tom here on purpose to say that at this price here of, let me go up here. So if French fries are running $4 for a serving of fries, and then this is at $3. Right? So if the market price of French fries is $4, how many is Tom buying? If the market price is $4, if the equilibrium price, if you will, in the market is $4, at a price of $4, how much is Tom buying? 0. He's out of the market, right? So at 4, Tom's out of the market. At 4, Dick buys 10, and Harry buys 3. And so at a price of $4, in the market composed of Tom, Dick, and Harry, they're going to sell 13 units of French fries, 13 bags of this. I'm thinking Five Guys here, so one of my favorite burger and fry joints. All right, so at a price of $3, Tom is still out of the market. Dick bumps up to 12, but Harry's even more responsive by jumping up to 5, I guess. Well, maybe that wasn't good. Wait, that's more. I went the wrong direction. Let's see. That's 3, that's 6. Looks like 9, right? So Harry was really responsive to a $1 price change. Harry increased his purchases by 6. Dick only increased purchases by 2, giving us a grand total of how much? In the market? How much is in the marketplace now at a price of 3? How many are being sold?
21.
21, right? So we got 12 plus 9 equals 21. And now that gives us another point on the market demand curve. And then finally, let's just do one more here. We down to $2. It doesn't matter if your scaling's off a little here. Now, of course, Tom jumps into the market and says, awesome, I can jump in with some fry purchases and grab 10. Dick marches along with 14. And finally, Harry's coming in here at, let's go, 13. Doesn't have to be linear. I got that drawn as a line, but maybe that'll screw you up. Maybe I should do a line. Let's say that's 50. I don't want to screw up since we're doing straight lines. That rise over the run should be the same. All right, so now I got 10 plus 14 is 24, plus 15 is 39. And so this is big Q, what we've been doing so far in our supply and demand chapter 3 stuff, big Q. And so the point with all this is twofold. One, to show you how we derive the market demand curve. So the market demand curve here, the big D that we talk about, is the sum of the individual demands. How we'll do that with our equation goggles is that big Q is equal to the sum of the little QI's, I equal 1 to N, if there's N individuals. In this case, there's just Tom, Dick, and me. So in our case, N equals 1. It's just Q1 plus Q2 plus Q3, right? All we're doing is we're simply adding them up. And we call this the horizontal sum. You'll see this in the textbook or homework problems. The market quantity is the horizontal sum, because we're going this way, the horizontal sum of the individual domains. All right, questions so far on that? So individual people translating into this market demand curve. All right, so we did consumer surplus, which was what? What was the definition of consumer surplus from last time? Let me go to the back of the room here. Good. So difference between what a consumer is willing to pay and what they actually pay for each unit consumed. So if Tom is indeed consuming 10 units, he got a little consumer surplus on the 5th unit consumed because he was willing to pay this, actually paid this. Willing, actual, willing, actual, willing, actual, willing, actual. At a price of $10, at a price of $2, he consumed 10 units. And so the consumer surplus is that area. Dick, likewise, at a price of $2, for the 12th unit, we already determined that he was willing to pay $3. But if the market price happened to be $2, he enjoyed $2 or $1 worth of consumer surplus on the 12th unit, and even more on the 10th unit. And so for this extends all the way up out of our space here. Dick's consumer surplus looks like that. And finally, Harry, same thing. It's a dollar value measure. If we take what you'll end up doing on some of your problems is you'll have to find the area of a triangle. So for Harry, actually, let me do Tom. It's better because I have everything I need. So you might find a test question or a homework problem. What is Tom's consumer surplus? 5? You're close. I want you to just be a little more careful. 5 what? 5%. No. 5 units of beer. $5. So consumer surplus is the dollar value measure of benefit that you get. So it is expressed in dollars. So how do we find the area of this triangle? Who remembers geometry class? 1/2 base times height. Good. So consumer surplus, in this case, for this little triangle area, equals 1/2 base times height is our area of a triangle. So 1/2 of a base of 10 units times a height of $1 is where we get our $10 divided by 2 is $5. So Tom enjoyed $5 worth of benefit, $5 worth of consumer surplus from the market when French fries were priced at $2. And then we can do the same thing for Dick, same thing for Harry. And then ultimately, this area over here is reflecting the same thing. The consumer surplus for the market. All right, so your textbook in chapter 5 has some nice pictures of this and also of producer surplus. I'm not going to do the producer surplus one today in class because it's the same concept except you got a supply curve. Pizza time, Pizza Village, Pizza Hut. Different prices, different producer surpluses. The market is the supply of the individual pizzas in the marketplace to get the market supply curve. So you got the same thing going on with producer surplus, which we did last time. We defined producer surplus, but relating the individual supply curves to the market supply curves. Same concept. All right, questions or comments there? All right, so the last thing with this chapter 5, and then remember I jumped chapter 4, I'm going to come back to that one here shortly, is deadweight loss, which we did talk about. I think I mentioned it. Deadweight loss. DWL. So deadweight loss occurs when marginal benefit does not equal marginal cost for some quantity exchanged. Marginal benefit does not equal marginal cost. Thank you. When marginal benefit does not equal marginal cost for some unit consumed. So I want to draw 2 graphs side by side with each other to look at this. I'd like you to make them basically equal to each other is the point I'm trying to make. So try to draw 2 graphs that are basically mirror images of each other, or not, I don't know if it's a mirror or not, but basically the same dimensions. Go ahead and draw home base. with home base, we've got some initial starting price in equilibrium and some initial quantity. And same thing over here. Okay. On the graph to the left, if there is no issues with the circumstances of the market, and we allow buyers and sellers to voluntarily trade with each other, kind of Tom and Jen on the island, they're both voluntarily doing what they want with their coconuts and their fish, then we get the value for consumers equal to this triangle, and the producer surplus equal to this triangle. And so the argument is that society's welfare, society's well-being is the sum of the consumer surplus plus the producer surplus. And if you think back to the government not being involved, which we will bring them back into the picture, but in the free market system, we've got consumers and we've got businesses, and we're saying that society's welfare, or a reflection of society's well-being, is the sum of consumers surplus and producer surplus. Okay, that's it. So that's society's welfare is the sum of those two. Now, a deadweight loss occurs when we're operating at a quantity where marginal benefit does not equal marginal cost. So remember, the supply curve, it's oftentimes not written on there, so you kind of need those magic goggles to put on, and remember that the supply curve is the marginal cost curve from Chapter 2, and the demand curve is reflecting the benefits of the consumers, the marginal benefit. At equilibrium, those two things are equal to each other. In other words, we're being efficient. But if through some sort of regulation, for instance, that says we're not going to allow, we think that there's too many units here, and some sort of regulated quantity set by law is short of this amount. Right? So this is the market quantity if we just left it alone. But through some sort of regulation or requirement, we're at a different quantity other than that one. We go up to the marginal benefit curve to read off the marginal benefit of that last unit consumed. And we go up to the, I went up to marginal benefit, up to the marginal cost curve to read off the marginal cost associated with that. So there's still units being traded between consumers and producers, right? So there's still people buying this number of units. Let me put a little bit of numbers on here, because sometimes I don't like to leave it so abstract. So let's say 150 units were being traded by the market. But because of this regulation, maybe there's something that we think is bad for the environment, and they think that's too much. And we're going to kill some people 200 years from now, so let's restrict quantities today down to 100. If that's the case, then the marginal benefit and the marginal cost don't equal each other. Consumers and producers still have some exchange going on. For the producers, it's actually allowed them to raise the price up, potentially. Because of that restriction, they can now charge a higher price. But there's still some consumers out there that get some consumer surplus. But the producer surplus, which used to be here, is now even bigger. And it looks like a little trapezoid. That is the producer surplus. The restriction has allowed them to charge a higher price, perhaps. And so now society's well-being is this trapezoid here. Consumers plus producers, same thing we were doing over here, by the way, right? Consumers plus producers. Is this area bigger or smaller than this area? Smaller. The way, again, if we drew it perfect. And so we're missing out on some benefit that was somebody's. And that benefit is the deadweight loss. This triangular region in here is the area of deadweight loss. It's what we used to have when we didn't have an issue going on. We didn't have these restrictions in the market. And by the way, the environmental example was probably not the best example. It'd be better to have, assuming that there is environmental damage, which scientists do differ on the opinion of the magnitude and size. But if there's really some sort of damage going on, then it's actually efficient to do that. We're going to get to that in like chapter a long ways now. Module 8, we'll talk about. So we're going to get there. But right now, I just want you to imagine some sort of restriction. Maybe it's just a dictator in a country that says, I don't think that's right, we're just going to cut back production, right? So they arbitrarily say we're going to only do 100 units. Might be a good way to think about it at this point in time. So if we're not operating at this level here, we're not allocatively. So this quantity, the market quantity, let's put a little subscript AE, which stood for allocative efficiency, which is the definition that I gave you before, right? When marginal benefit equals marginal cost, we're said to be allocatively efficient. The same is true if we are operating over here. So if we're overproducing the good relative to where the market would be, we're going to have a triangular region right here that is also a deadweight loss. We could be doing better. And I'm not going to draw that one on the board. We're going to, when we get to next module next week, that's where we're going to hit this hard. We're going to talk about taxes and regulations and subsidies and minimum wage and all kinds of different things that can go on in the real world. And then this is our toolbox to analyze the impacts of those things. So this chapter 5 is just kind of setting the stage of the basics of consumer and producer surplus and deadweight loss. All right, any questions? All right. Chapter 4. Elasticity 4. This is chapter 5. Now we're going backwards to chapter 4. All right, so we ran into that problem when both curves shifted. What happened? Look back in your notes from Wednesday. When both curves shifted, what happened to equilibrium price and quantity? They changed. That's, well, not even totally for sure, but what happened? What was that little shortcut thing that I said, kind of keep this in mind? When both curves shift, one is, yeah, we'll be sure about one. Go ahead, whoever was saying that.
We'll not be sure about the variable or about variable about one price or quantity.
Okay, we're going to be sure about one thing and unsure about the other. And she's gone today. Emma? Was that Emma who was back there? Yeah, it was gone today. Okay, so Emma brought up the answer to that of why that was the case. And the reason was we didn't know the sizes of the shifts, whether it was a big demand shift and a small supply shift, or a big supply shift and a small demand shift, or a small demand shift. So today we're going to get into more quantitative stuff. So let's just put a little note. Demand and supply chapter tend to be tend to be more qualitative in their reasoning. For example, an increase in demand leads to an increase in price, right? So we had the directions of the change. The focus was on the directions of the change, but not necessarily the magnitude of the change. Although we did get a little bit into that if it was given to you. So, chapter 4 looks closer at quantitative changes. Quantitative changes. So, economists don't get paid 6 figures to tell the CEO of Pepsi, hey, if you do some advertising, you'll increase demand, and that'll allow you to get a higher price. Okay? They had Econ 101 likely to, not all of them, not all of the CEOs, but they get that, right? If they're in business and they're doing okay, they get this part. So the economists contribute something more like this. If you increase advertising by 10%, I think that's going to lead to an increase in price of 3% and be more precise with the changes, right? So we're going to get a little bit more precise with the quantitative changes. And what we call that is the elasticity of demand. The elasticity of demand, which I'm going to use the symbol sigma subscript D, the elasticity of demand. If you want to put in parentheses here, kind of the price elasticity of demand, but usually it's just elasticity of demand. And the elasticity of demand is a number that shows, it's a number that shows the responsiveness of quantity demanded to a change in price. It's a number that shows the responsiveness of quantity demanded to change in price. All right, so let's put 2 graphs side by side with each other. And on the graph to the right, it's just trying to draw a regular old demand curve. And the one on the right, draw kind of a steep demand curve. Which one of these is more elastic? Which shows a greater responsiveness to a change in price? The one on the left or the one on the right? Ike?
The
one on the left. Okay, why do you say that?
Because you know what price you go at, the value of quantity you're going to chase.
Okay, and so we can kind of test that by taking 2 prices. I wanted to draw these side by side so that maybe we could do a price of, oh, let's say $10 to $8. Right? If I take a $10 price change and an $8 price change, then there's a change in the quantity demanded, moving from points A to B perhaps here. So we've got point 1 to point 2. Let me go A to B. Point A to B. And that corresponds with this quantity down here at a price of $10. Maybe it was 100, and at a price of $8, it was 140. So my quantity demanded when I went from P1, let's call it, to P2, from $10 to $8, my 1 corresponded with Q1 down here. Quantity demanded was at 100. Drop in price, law of demand says I'm going to sell more units, and I increase the quantity to Q2. Drop in price, increase in quantity. Now, if you take those numbers and run them across, that change, that same change from 10 to 8, if our scaling was the same for quantity, clearly leads to a smaller change in Q1 and Q2. And so the left demand curve would be said to be more elastic. This one would be less elastic. So we're kind of getting into graphically here with straight line demand curves, the steepness or flatness of the demand curve, right? So if I take this and I do this, is this demand curve now more elastic or less elastic? More, right? So it's more elastic all the way down to possibly here, and then as I start to make it steeper and steeper, it becomes less elastic, less responsive. So it's the steepness of the curve that we're looking at in this chapter specifically that deals with quantifying these numbers. All right. Okay. So here's it's equation goggle time. So here it is. The elasticity of demand is equal to the percentage change in quantity demanded divided by the percentage change in price. It's the ratio of the percentage change in quantity divided by the percentage change in price. So remember my notation here, this is the change, percentage change in each variable. So how do we calculate percentage changes? You would have learned this in math class for sure. You can learn it in biology with looking at the rate change of a tree during its growing season or something, or the fruit on the tree, it has a rate of growth. Who's got the percentage change in variable x, basically? Whatever x turns out to be. From math class, how do we do that? Okay, yeah, you're using this number, so 140 minus 100, so you're taking kind of the new number minus the old number. I mean, that's one way that I like to use. So the new number minus the old number, and then what? Divided by the average. That's correct. I'll just cut to the chase because I don't want to make this like a hocus pocus show. That's correct for this chapter, but that's not the normal way that we do rate of change. That's what I want to explain. So what's the normal way we do that? New number minus the old number divided by the old number. Yeah, it's just the old number typically. So the new number minus the old number divided by the old number. So in other words, for the percentage change in quantity, the way we normally do it would be 140 minus 100 divided by 100 would be a 40% increase in quantity, right? 40% increase in quantity. Now, what if the roles were reversed? If we follow that thing and I make the new number and the old number different, it would be 100 minus 140 divided by 140.
Should get a negative.
And is this number going to be bigger or smaller than 40? Smaller, right? Because the denominator switched on us. So when the number shrinks, it comes up with a different answer than when it grows. And that's something that kind of doesn't work quite right with these elasticities, and that's what I want to highlight to you. But this is the normal way that you do it. Yes, question? You can have a negative number for the percentage change, and yes, ultimately there can be a negative number for the elasticity. Yep, and we'll talk more about that. So the denominator is what's causing the problem here. Let me put both up here with 100 divided by, this is the first one we did. Check it out. The numerator's fine, right? We've got a 40 unit change and a 40 unit change. The problem comes in with this denominator, that the old number switches on us depending if we're increasing or decreasing. And so the thing we're going to do for this, because we want to be able to go back and forth and be fair with it, if you will. So a price decrease and a price increase, we want to have the same number for the calculation of the elasticity. And so our trick that we're going to do, our convention, which, by the way, there could be other conventions to fixing this, but we're going to take the average of the two numbers. So somebody already said it. I know some of you have worked ahead, which is awesome. And so instead of dividing by the old number, we're going to divide by the average for this purpose. So for this, let me blow this out a little bit further. We've got the change in quantity divided by the average quantity. The change in price divided by the average price. Which then, in all its glory, ends up being the new number minus the old number up top. So if we do the Q2, Q1 business, you could put new if you want. Q2 minus Q1 divided by the average, which is Q2 plus Q1 divided by 2. Now, half the time we just kind of know the answer. Oh, well, it's 9. The average of those two is 9, right? But it's really 10 plus 8. 10 plus 8 is 18, divided by 2 is 9, right? So that's the average divided by P2 minus P1, new number minus old number, divided by the average price, which is P1 plus P2, or P2 plus P1, doesn't matter what order you do it with, divided by 2. That's the average price. So this is this ugly formula in all its glory. And depending on the type of problem we're doing, don't think that you only have to know one or the other. You kind of need to know both. So this part of the equation is just as important as this one, actually cranking out the numbers. So you kind of need to know both. So let's do it. Why don't you guys start working on this yourself? P1, P2. So we did a price decrease. Make sure you follow all of the numbers and tell me what the elasticity of demand is for this set of numbers. We got 100 and 140, 10 and 8. I'll walk around the room. You guys can start cranking it out and tell me if you got any questions. But it's basically just a plug and chug, plug and chug. Well, you're going to use this one for this one because we have specific numbers. I was just highlighting that. I might continue right there. A lot better you know that. Yeah. Did everybody get on the sign-in sheet? I didn't. Okay. Oh, okay, what do we got for answers? Just kind of blob. Give me your answers. Well, let's see who's right. I don't even have this worked out, I don't think. Oh. Huh?
-1.
-1. Anybody else? You got 4. +4? Is that right? +4? Okay, +4, -1. Other answers? 3. +3? +3. Other answers? Did you guys get answers? So let me take another pass here. Ask me if you got questions. You're just plugging and chugging. So you need to plug in the Q2. So Q2 is 140, right? 140 minus 100. Now you could kind of shortcut, just put 40 if you want. 40 divided by the average of the two is 120, right? So 40 divided by 120. And then kind of do the same thing for the P2 and the It's real important. I want to see some numbers on your paper. I'm going to walk around and just raise your hand. I want to help you out with this. Okay, we have another answer of 3 halves. 1.5, which is 3 halves. Okay, so we got a 3 halves and a 1.5. Are those positive or negative? Positive and positive. Positive and positive. Somebody else said what? And you've got negative. Okay, and I got a -1. -3 halves. All right, I'm starting to see more and more answers here of either 3 halves, 1.5, -3 halves, -1.5. All right. So let's see here. Where do we end up? So we've got, following this rule here of 140, and what you're doing is plugging and chugging the whole thing. So 140 minus 100 divided by the average of the two, which I'm just going to shortcut to 120, divided by P2 minus P1. P2 is an 8. 8 minus 10 divided by the average of the two, which is 9. So we get 40 over 120, which we could knock out these zeros if we want. That'd be kind of fun. And 2, -2 over 9. And then what can we do? You guys can pull out your calculators at this point, but we can go 4 twelfths times 9 halves. Invert the fraction in the denominator, flip it over, multiply it times the numerator. -36 times 12 times 2 is 24. You got that too? Okay. So what can we break this down to? Divide by 12. 3 halves. Negative. -1.5. So good job. A lot of you came up with that, right? So our number that shows the elasticity of demand over this range is 1.5. -1.5. On your graph, we usually show this kind of centered up between these 2 points because we calculated it at around that average number. And so the elasticity of demand is equal to -1.5 or 3 halves. Either way is fine with that. I don't care which one you use, 1.5 or 3 halves. Oh, okay, questions?
Does it have a unit on the back, or is it just 1.5?
Okay, good question. And I was going to come there later, but now I'm coming there now. What are the units? $1.5, 1.5%, 1.5 units of beer, dollars per quantity, a percent. This is really kind of a tough question. It turns out to be a unitless number. It is possible to have a unitless number. They all kind of cancel with each other because it's a percent divided by percent. So it's actually a unitless number. So I want you to add that to your definition. A unitless number. Not meaningless, unitless. Okay, so hopefully there's some meaning here. And what is the meaning then of this? Well, to get the meaning of it, I want to do another little shortcut method. So what does the elasticity of demand equal to negative 1.5 mean? Question mark. When you go to the CEO of Pepsi that's paying you 6 figures, if you tell them, well, the elasticity of demand is negative 1.5, that's like wah, 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 right? They don't care about that. They don't want to hear economic jargon. You need to be able to interpret what that means. And so one of the things you can do is to fall back on this thing, negative 1.5. What can I do with any number to preserve it and make it still a number but turn it into a fraction? Put it over 1. You can take any number, put it over 1, and it's still a fraction. And then what's beautiful about this is that it runs, now you've got the meaning almost instantly, right? Because the percentage change in quantity demanded is up top, the percentage change in the price is on the bottom, and the meaning is a 1% increase in price will lead to a 1.5% decrease in quantity demanded. So if you, and I'm going to write it out. So if you raise the price by 1%, your quantity is going to fall by 1.5%. All right, so here we go. A 1% increase in price, a 1% increase in price will lead to a 1.5% decrease in quantity demanded. A 1% increase in price will lead to a 1.5% decrease in quantity demanded. Now, if you think about that definition, it's real close to the law of demand, but it's stronger. Law of demand said increase price, what happens to quantity? Goes increase price, what happens to quantity demanded? It goes down, ceteris paribus. This is saying, hey, we can measure this stuff. Depending on the elasticity of demand, a 1% increase in price will lead to a 1.5% decrease in quantity demanded. All right, questions there? All right, if we do another price decrease from $8 to $6, so suppose that P3 now is 6, what does quantity go up to? So it's a straight line, 160. 160? I hear yes. Yes, sure.
180.
If this is a straight line, 180. Rise over run. If this is a straight line, down 2 over 40, which means down 2 gets you another 40. We're up to 180 is Q3. What do you think the elasticity of demand is right here between these new units? 1.5? Same thing? All right, just because we need a little practice, go ahead and actually plug and chug the numbers again. See if you find a surprise. Plug and chug the numbers. Go through the formula. Don't assume that you know the answer. It only makes an ass out of you and me. All right? So now your Q, yeah, so the new number now is the 3 number, 6. So new number minus the old, we're going from 8 to 6 now. So just in between here, not back to the original number. So P2 and P3 are your new number, old number business. And first person with an answer, shout it out. Negative 7/8. Okay. That was quick. We don't have time to erase here. All right, so negative 7/8. Give you a hint, it's not going to be 1.5. I don't even know the answer. I don't have it worked out yet. So just show your work. We're going to work it out together afterwards, but I don't and make this stuff up. I'm relying on you guys for the right answers. You had 7, 8?
Yes.
I see a -4. Anybody else?
I'm -1.
What do you have?
-1.
-1.
Negative 8 over 7.
-8 over 7. Yes.
I got a positive 7, 8.
Positive 7, 8. Okay. No, you didn't. There's a withdrawal. Okay. What else? How many people support one of these answers? Which one? Give me, shout it out.
Negative 7, 8.
7, 8. Negative 7, 8. Okay. All right. So let's check out. Let's make sure we're all on the same page here. So we got new number, the old number with quantity 180 minus 40. As we said, that's 40. But now we've got a new average, and this is where the number changes on us, right? 140 over 160 is the new average, and on the price we have a -2 again, like we had before, but the average changes to 7. So there's the start off. Following our formula, we end up getting that, which equals what? 4 over 16 times 7 over 2, negative 28 over 32. And that equals, we can reduce it down. Looks like our 7 8 people are doing pretty good here, right? So we can reduce that down to -7 8. All right, so let me address you. Why did you withdraw your positive?
I got to carry a negative.
Just forgot to carry a negative. Now let me give you, and I'm glad you brought up the positive thing. Why is it not positive? Because this is like a multiple choice type of question, by the way, for a test or something too. Or were you just stretching?
Yeah.
Okay. The slope's negative, the price, right? It's the law of demand. So on a multiple choice problem, why is the elasticity of demand always negative? It's because of the law of demand. Price goes up, quantity goes down. They're always moving in opposite directions. No matter which direction you move, if we do a price increase from 6 to 8, then this will be positive, but this will be negative, right? We're just flip-flopping. So one of the things here is that the elasticity of demand, so key point, the elasticity of demand is always negative due to the law of demand. Elasticity of demand is always negative due to the law of demand. But to mess with students, we talk about it as a positive. Because we all know it's negative. And really, I can't think of any other reason other than to mess with students. It's all I've come up with my 25 years of teaching this stuff. So to mess with students, we talk about it as a positive. More formally, if you're a mathematical person, what are we doing to it? To change a number to a positive, what's that special thing we can do in math class? Yeah, I'm not even getting that fancy, but you're right. You can do some multiplications doing this. This is the symbol. Absolute value, yes. So we think of it in terms of absolute value. Absolute value. So I want you to take special note of this because I will be a little careful, or I will count you wrong, I guess, on a test if you give me the elasticity of demand equals 1.5. That is wrong. In written form, on a short answer problem, if you write that, that's wrong. The correct answer is the elasticity of demand is equal to negative 1.5. But I will also accept the absolute value of the elasticity of demand is equal to 1.5. So you got to do one or the other. Put the negative sign there or put the absolute value sign there. That way I know that you know the law of demand, that it's really always supposed to be negative. Okay, questions there? All right, so the elasticity of demand changed from here to here to this negative 7/8. If we went this direction, what would happen? We went from, I'm not going to work out all the details here, but if we went from 10 to 12, what would happen to the number? And this is where it becomes easier to talk in terms of absolute value. Would the number in absolute value get bigger or smaller? Bigger, right? It gets bigger. So it actually changes anywhere along here. And to reason that out in our head, it's good to come back to this formula. It's the ratio of the percentage changes. So if I'm over here at a quantity of 1, and I go from 1 to 2, quantity from 1 to 2, what have I approximated percentage-wise? Using kind of the old school method, going from 1 to 2, what percentage change is that, going from 1 to 2? What percent? 100%, right? It's a doubling of it. From 1 to 2, that's a big percentage change. It went from 1 to 2, big percentage change. Whereas if I go from 100 to 101, what's the percentage change? 1%. Same 1 unit change, but in percentage change, when you have bigger quantities, the percentage change becomes smaller. When you have low quantities, it becomes bigger. Same thing's going on for price. If I go from $1 to $2, that's like 100% change in price. But from $10 to $11, it's just a 10% change in price. And so as we move along the demand curve, I'm getting to bigger quantities, smaller prices as I move this direction. Bigger quantities, bigger quantities, but smaller percentage changes, right? Smaller percentage changes in quantities and bigger prices. And so those two things are moving, and that's what's causing this to change along the way. All right, so what are the ranges possible? I think I'm going to go here. So the range of the elasticity of demand. And we'll talk about it in terms of absolute value. The range of the elasticity. Burning up all of them. I need my blue. I need my blue. So what do you think? As we move this way, you have the right answer. What happens if we do it like really, 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 really close to the horizontal axis? What happens to that number? How big does it get? How big can it get? What's that? Technically small. Okay, so small and negative numbers?
Yeah.
Yeah, small and negative numbers. So in absolute value, it's getting really big. That's why we talk about this absolute value thing. Actually helps this discussion a little bit. So the range of elasticities ends up being between 0 and the number that shows the responsiveness of quantity demanded to price changes is possible to range between 0 and infinity. All right, so let's draw a new graph. And for this one, I want you to draw it so that the demand curve intersects the vertical axis somewhere and the horizontal. I don't really care if it's steep, but I do want you to connect the two. Over this range, if you bisect the midpoint here, between here and here, which I don't think I did a very good job, maybe it's here, and go straight up, whether you got a flat curve or a small curve, something special happens there that we'll explore a little bit later, but the elasticity of demand in absolute value equals 1. We saw that here. We went from 7/8 up to 1.5, so somewhere along the linear demand curve it equals 1. It turns out to happen at this midpoint, is the way it shakes out. No, it's not equilibrium. It kind of is what it is, and what it is that at this point, what's true about the percentage change in quantity versus the, whoops, kind of showing my cards there. These guys might have saw that, but what's true about the percentage change in quantity versus the percentage change in price? They're equal, right? So as elasticity, somewhere in the middle, those two things happen to be equal to each other. But it's not really any form of equilibrium. It just kind of is what it is at that point. All right, so then over this range, this upper portion, they're all bigger than 1. So over here, the absolute value of the elasticity of demand is greater than 1. And so the percentage change in quantity versus the percentage change in price, what's going on? Which one's bigger? For this to be greater than 1, which one's bigger? Price? Go back here. Quantity. The upstairs is bigger than the downstairs, right? So in order for this expression to be bigger than 1, this has to be true. And then finally down here, again, by definition, the way we did this, the absolute value of the elasticity of demand is less than 1. And the percentage change in the quantity demanded is now less than the percentage change in the price. Now, as we approach and get infinitely close to the vertical axis, it basically, if you want to put on, goes to infinity. And the reason it blows up or heads close to infinity is because of what's going on with the quantity changes, right? Remember 1 to 2 was really big. Well, we can get them infinitely big. And then down here, it approaches 0. So between 0 and infinity is the range. That's what I wrote for you up here. And that's the way it shakes down. Now, is a number greater than 1 or less than 1 more responsive? To get back to how I originally defined elasticity, it's a number that shows the responsiveness of quantity demanded to a price change. Which one's more responsive? One that lives up here or one that lives down here?
Greater than 1.
Greater than 1? I heard some other people kind of throwing their hand this direction. Right? Because check it out, the quantity effect is bigger than the price effect. So you raise prices by, if the elasticity was 2, you raise prices by 2%, you sell 20% more, right? That's a big response. If we tie that back to the demand curve, it would be the flatter demand curve, right? I change price and boom, I sell a whole bunch of product, right? So that's more elastic. So this is called the elastic range of the demand curve. The elastic range. Demand is said to be elastic, price elastic. This range, demand is said to be relatively inelastic. Relatively inelastic. Fairly unresponsive. I do a 10% change in price, and I only sell 1% more units. That kind of sucks, right? So demand is maybe unresponsive. And maybe that ends up being a good answer, because we're talking about decreasing, we're talking about losing sales, so maybe that's good. We'll come back to that theme later. But relatively inelastic demand. And then the middle one here, since it's equal to 1, it's just called unitary elastic. Unitary elastic, just to kind of complete the ranges. But that's just kind of an oddball case. We're going to fall into the elastic range or the inelastic range. All right. One thing I might point out here that I don't usually point out, but this seems like a good spot of any. If I was to calculate the number right here with this demand, how do you think that would compare with 1.5? Again, remember the scaling would be the same, like the units. So if that's 40 units, this is probably like 20 units or something small, right? How would that one compare? Do you think it would be bigger or smaller in absolute value, bigger or smaller compared to the 1.5? Smaller, right? So the percentage change in quantity, the upstairs, is less than what it was over here, right? The price is actually the same, but the percentage change in quantity is less, so it would be a smaller number than what we have over here. So as the demand curve starts to become taller and taller and steeper, this is my little memorization device that'll come in handy later, it starts to look like an eye, or inelastic. This demand curve tends to be more inelastic than this demand curve. And that's what we said before. I said more elastic, less elastic. You can think of this as being inelastic now. And to bring the terminology together. So inelastic. Again, this seems like as good a time as any. This demand curve, even though it's steep, still possesses these properties. So even though it's steep, if I take this sucker down to here, and then I don't want to get in trouble with the university, but up to there, right? Kind of extending that thing up. The midpoint is here. Go up to the demand curve. Right there is unitary elastic, right? But what's often the case is that those numbers are just kind of absurd, like we're not dealing with them. That's why I put dash, dash, dash. But the principles are still the same. Now check it out. Along this portion, what's true about the elasticity of demand? It's less than 1. It's all less than 1. It's all inelastic. It's all on this portion. And so we have all of those numbers less than 1 along there. But they're still going to change. It's still going to follow those same properties that we did before. Okay. Now, what are some goods that are relatively inelastic? In other words, consumers tend to be unresponsive to price changes. Drugs, Yeah, cocaine, pot, heroin especially, the elasticity of demand for heroin. By the way, economists do study this. The elasticity of demand for heroin is really low. So it's more inelastic than pot. Pot prices go up, maybe I'll go get drunk or I'll try some other novelty drug. You know, I'll just kind of shift around a little bit. But if you're a heroin addict, gotta have the heroin. Right? It's a very powerful drug. Okay, so drugs tend to be inelastic. What else? Cigarettes. Gosh, seems like all the fun stuff in life tends to be inelastic. So we got smokes and drugs. Gas. There's a legal one, right? Alcohol. But gasoline, we tend to not change our purchases very much. So gasoline would fall into that. Food, some food products especially, milk tends not to have too much price elasticity to it. Has a little bit more. It actually has a different one that we'll come back to later. What else? Cheese. You like your cheese? I don't know about cheese. Not sure where the cheese falls into. Now, let me brought it up. Havarti cheese or American cheese? Any cheeses. Now, if the price of Havarti cheese doubles, what are consumers likely to do? Buy American cheese. Now, if instead the price of cheese doubles, what are consumers likely to do? Buy less cheese, right? They might try, what's that? Eat a hamburger instead, right? So what I'm saying is, what has a greater elasticity of demand? Havarti cheese or cheese in general? Which one has a greater elasticity of demand? In other words, on these pictures, which one's Havarti and which one's cheese in general? To the left is cheese or Havarti? And of course, Havarti is a cheese, right? Or is this one cheese? And this one's Havarti. So let's go through the thought exercise again. If I double the price of Havarti, what do I go and do? Buy American, buy some other cheese, right? But if I double the price of all cheese, which one's going to be less responsive if I'm measuring cheese on the horizontal axis or Havarti cheese? Havarti here or cheese? Havarti will be steeper or flatter? Which one is there going to be a greater response to? The Havarti or the cheese example? The Havarti's more flat, right? Because you're going to go quit buying Havarti and go run to American or Munster or some other cheese, right? So if only Havarti cheese goes up, people are like, see ya, Havarti, I love you, but I can find 100 other white cheeses that will fix my cheese habit just as well. But if we look at all, let's say white cheeses, I guess, for some reason, that's going to be less elastic, right? Because you can't go run to something else very easily. So if we look at white cheeses, it would be this. If we look at all cheeses now, it would be even steeper. So part of what drives elasticity of demand is the availability of substitutes. The availability of substitutes is one of the key determinants to the elasticity of demand. So it's kind of how you define the good. Are we talking about cheese or are we talking about Havarti? So what determines the elasticity of demand? Question mark. Number one, the availability of substitutes. The more narrowly we define the good, the more elastic demand will be. The more narrowly we define the good, the more elastic the demand will be. So, 3 quick and dirty little graphs here. Havarti, since we did this example. I've never done this example before. I kind of like it. Havarti, white cheese, and finally cheese. Are we talking about the cheese market, the white cheese market, or the Havarti market? We could be talking about any of them. If there's a price change in Havarti, people will just run to another cheese. But as we just start to say, well, what if white cheeses go up by 20%? There's less places to run. And then finally, if we just define all cheeses go up by 20%, there's even less substitutes. Those people who are cheese lovers are just going to suck it up. I will easily pay double for cheese than what I do now. In fact, this is what we found with protecting the Wisconsin cheese folks, is that there's been regulations, government regulations on the cheese industry. Around the world, cheese is way cheaper in other countries than it is in the United States. And part of that is because the government is protecting the Wisconsin cheese. And of course, there's cheese made other places, but Wisconsin has been the #1 cheese producer in the United States for a long time. Okay, questions on that? What else determines your elasticity of demand? What has a greater elasticity of demand? A car or a pack of gum? Which one has a greater elasticity of demand? So if we were looking at this one versus this one, which one's the pack of gum and which one is the Ford Fusion? Yeah, I don't have numbers and stuff, but in general, what's going to make it more? The Ford is the one here or here? Which one has more price sensitivity? If I jacked up the price of gum by 20% versus jacking up the price of a Ford Fusion by 20%, which one's going to cause people to run more? Which one's going to have more of a response? The Ford, right? Because the pack of gum, it's like, okay, $1. I swear it was $1.20 the other day. It's $1.20, $1.40. I don't give a rip. Here we go. Put it on my bill, right? And so you put it on the conveyor belt. You don't care as much because it's not going to make or break you, right? So those goods end up being, those goods that are a smaller fraction of your income tend to be less elastic. So this would be the Ford Fusion, and this one would be the gum. And so the one that we're playing on here is the fraction of your income. So number 2 would be the fraction of income spent on the good. The higher the fraction, the more elastic demand will be. Holding all of the things constant, if that particular good makes up a large fraction of your income, then you're going to be more sensitive to price changes, is all we're saying. That elasticity number is going to be a little different. Number 3, any questions on that? Number 3 is the amount of time. The time allowed for adjustment. So how does that one work If you're used to buying broccoli at a certain price, and you have in mind a dinner tonight that has a broccoli side salad. Do you like those ones with the mayonnaise and the raisins? People either love that or hate it. I love that. The cold broccoli salad with the raisins and the mayonnaise and the sugar. Love it. And bacon, yeah, it's just a bonus. Anything's better with bacon. So you throw some bacon bits in there and you're off to the races. So if you run to the store that day and you had a dinner planned and broccoli prices are higher, are you going to not buy the broccoli? Not that day, right? You might end up buying it even if the price is higher because you had it planned. So if we look at the demand today for broccoli, that's going to be different than maybe the demand for the week or the demand for the month. If broccoli prices continue to rise, you might start thinking, you know what, the salad would be pretty good with cauliflower too, because I'm not going to pay $20 for a thing of broccoli, right? So you start to think, you start to change your behavior if you have enough time to change your behavior on, right? So the amount of time allowed for adjustment makes a difference on how elastic the demand will be. So more time leads to more elastic demand. And I think the easiest to think about this is that it gives you more time to look for substitutes. So the key point here is you have more time to look for substitutes, which really ties it back into number one, the availability of substitutes. There's more substitutes available if we look at a longer time period. Okay, questions on that? All right, it's time to get extreme. We've got some extreme sports nowadays, which are now mainline sports, but when I was your guys' age, water skiing and wakeboarding and mountain biking and whatever, some of those sports, the extreme sports, were kind of the new thing. And so now we got some extreme econ. We're getting crazy for economics class here, extreme econ. And I want to show you two extreme demand curves. The first one is perfectly flat. I know it's crazy to think about. And then the one on the right is perfectly steep. So it kind of looks like I got a little tilted here. This is supposed to be perfectly vertical. All right, and so with these demand curves, we can kind of think about the price change, P1 equals P2, new number minus old number. And we can think about some sort of Q1 and Q2. And so what is this elasticity equal to? The elasticity of demand is equal to the percentage change in quantity demanded divided by the percentage change in price. We've got some number. This is just like the ones we did before, Q2 minus Q1 divided by the average of 2. So we get some number divided by P2 minus P1 equals 0 equals 0. Right? Some number divided by 0. Yes? Undefined. Oh, so somebody's got that nagging 5th grade teacher in the back of their mind that says, listen here, there's one rule that you got to remember. You can't divide by 0. It's illegal. I So you couldn't divide by 0 because it was undefined. All right, well now that you're in college, we're going to trick that old granny, that's probably retired now that you guys are up there. And instead of dividing by 0, let's divide by something really close to 0, because that's totally legal. We can't divide by 0, but how about some number divided by 1 over 1 million? 1/millionth. Is that legit? Yeah. Now I can see some of you are squirming in your seats, but Russ, that's not close enough to being undefined. So get a little closer. How about 1 over 100 million? In other words, on the number line, all we're doing is we're going, if this is negative infinity to infinity, and this is a 0 somewhere in here, why don't you guys just get cozy, get comfy cozy to 0? Maybe how about 1 over 1 trillion? 1 trillionth. Keep getting closer and closer to 0 until you're comfortable. Okay, everybody do that. Whatever that number needs to be. Now, when we have a fraction in the denominator, how do we solve this problem? Flip it and multiply it by the numerator. So the smaller you get here, the bigger the whole thing gets. Divide by 1 million, 100 million, 1 trillion, 1 zillion, 1 gagillion, whatever. That makes this whole expression blow up to infinity. It gets as big as you want it to be. As the 5th grade teacher said, it's undefined. Well, define infinity. I can't. It's like not a number. It's kind of a number, but it's really, really big. That's all. Right? It's undefined. So this is, for those of you who haven't had calculus class, you just took your first limit of an expression as it's approaching 0. You did a little bit of calculus here. But all you have to really know is that it's infinity. So if you want to just memorize that it's infinity, but I like to kind of go back to this. So the elasticity of demand here is infinity. It's perfectly elastic. Perfectly elastic. The elasticity of demand in absolute value is infinity. If you've got a perfectly horizontal demand curve. Doing the same thing over here, we've got a P1 and a P2. It's just the opposite. Q1 equals Q2. Elasticity of demand is equal to 0 divided by some number. We're just reversing it. Is this one negative infinity?
No.
When the 0 is up top, what did 5th grade teacher say? 0. It's 0. You can divide 0 divided by any number is still 0. And so that one's legit. So this one is perfectly inelastic. Perfectly inelastic. All right. Well, we've had so much fun with price elasticities that we need to apply the concept to a couple other things. We had a whole bunch of things that were important for demand other than price. So one of those things was income, right? So we also have an income elasticity. An income elasticity. And it is a number that shows the responsiveness of quantity to changes in income. I'm not going to write that out, but it's the same thing you had before. The income elasticity is the percentage change in quantity demanded divided by a percentage change in income instead of price. Same formula, substituting income in for price. All right, so suppose let's do a little example for this one. suppose a 10% increase in income leads to a 5% decrease in quantity sold. Suppose a 10% increase in income leads to a 5% decrease in quantity sold. What would the income elasticity be equal to? What'd you say? 1/2, right? So this is where we use this definition, not the one I gave you before. So you do have to know both, but we've got the percentage change in quantity is 5%, and the income went up by 10%. Negative or positive? Negative, because it's a decrease here. So this is a decrease in 5%, giving us a negative 0.5. Now wait a second, does that even make sense? Income goes up and I buy less?
Yes.
Is it always negative? Is that the way it always works? What does it work that way for? Inferior goods, ramen noodles, right? So is it possible for the income elasticity to be positive or negative? Yes. And that ties us back to the chapter 3 shifter stuff of normal and inferior goods. All right, so if the income elasticity is less than 0, meaning it's a negative sign, if the income elasticity is less than 0, then the good is inferior. So this would be ramen noodles. If the income elasticity is greater than 0, meaning it's positive, then the good is normal. That was our steaks and hamburgers, and most goods are normal goods. Now, what if it's equal to 0? What does that tell you? What if it's basically equal to 0? What's the connection? It's I want to be careful with the elastic. It's not inferior, it's not normal, but I want to avoid kind of the price elasticity stuff because I'm just looking at income.
Constant? Oh.
Constant?
It's a necessity.
Yeah, it gets closer to being a necessity. There's necessity in luxury goods, but that actually pivots on the value of 1, not 0. It's kind of close to that concept that's our pivot, but it's not unitary. How big of an impact does income have on purchases of this particular good? 0. In other words, you get, and when I said milk before, milk is close to 0. So right now, if you're poor and you're at the poverty line, and now all of a sudden you triple your income, you don't drink more milk for the most part. You were having your bowl of cereal and you had your glass of milk and your bedtime milk or whatever, but your consumption of milk is pretty much independent of your income. And so milk falls into this category. They're kind of, the two are unrelated. Income and purchases of this good are unrelated. And if you want to put down an example, milk is an example of this. Where it really doesn't matter if you're rich or poor in terms of income, you end up consuming about the same amount of milk. Okay. The cross price elasticity. Remember the price of related goods? If the price of Pepsi goes up, I buy more or less Coke. Price of Pepsi goes up, I buy more Coke. They're positively related, right? So our next category measures the responsiveness of that, and it's called the cross price elasticity. The cross price elasticity. And its formula is pretty simple. This one I'm going to put, let's say, Coke compared to a change in the price of the related good, Pepsi. So notice it's very similar, but with the price elasticity, we use the price of Coke. But now we're substituting in the price of Pepsi. We're saying, hey, if Pepsi goes up by 10%, what happens to Coke sales? That's what So, what do you expect the sign of this elasticity to be? Greater than 0 or less than 0? For Coke and Pepsi, greater, right? If the price of Pepsi goes up, Coke sales go up. Price of Pepsi goes down, Coke sales go down. They move together. So if the cross price elasticity is a positive sign, greater than 0, then the goods are substitutes. If the cross price elasticity is less than 0, what are the goods? Complements. Tying it right back to our demand shifters. Price of peanut butter goes up, I buy less jelly. Right? They move in opposite direction. All right, so sign matters. What if it's equal to 0? They're unrelated. Then unrelated. So, moral of the story, unlike the price elasticity of demand, sign matters. Maybe size matters too, but sign matters with income and cross-price elasticities. So note, sign matters. The sign of the elasticity is going to tell you if it's a normal or inferior good. The sign is going to determine whether the two goods are substitutes or complements. And then possibly unrelated. All right. That looks like a good place to wrap it up. That is chapter 3. We're done. I know. There was one more thing that I could have a bonus round if you guys want to stick around.